Good afternoon. My name is Joe Drumgoole and I'm Director of Developer Advocacy at MongoDB. I'm not going to talk much about MongoDB today, a little bit at the end. I really wanted to talk about this event sourcing thing. So two quick questions. Who here has heard of MongoDB? Awesome. Who here has heard of event sourcing? Even better. Is it not the goofiest name you've ever come across in the history of computing? It tells you nothing about what it does. We're just really bad at picking names for technology as technologists. Somebody should call the marketing department. I mean, command, query, responsibility segregation is terrible, but at least it says something about what it's doing. Event sourcing, when I first came across it, I either thought it was something to do with marketing events, or I don't know, maybe there's an event source somewhere in this system. So one of my other developer advocate friends in MongoDB piqued my interest about this about 6 months ago, and what I loved about it is it talks to me about stuff I can relate to in the real world and stuff that I can use pretty much at any level that I'm building a system. We see, or I've seen lots of architecture talks today about building systems that massively scale and multiple microservice architectures. Let me ask another question for you. Who here is building a system today that has 1,000 or more concurrent users? Put your hands up. Who here is building a system today that has 10,000 concurrent users? Leave your hands up if it's 10,000. Right. So most of us are building systems that could probably run pretty adequately on SQLite. That's the reality, right? You run SQLite on a big server, it's pretty powerful. And if you don't like that, you can whip to MySQL server or a very small instance of MongoDB. The point is, for a lot of the systems we're building, we don't need these architectural conceits. And the nice about event sourcing is it isn't an architectural conceit. You can start with it small and grow into it as you grow into your architecture. So it's not a new idea. Event sourcing was invented by this guy, Luca Pacioli, in Italy in the 15th century. This man is the inventor of double entry accounting. Who here is an accountant? Awesome, because you'd be in the wrong conference. Double entry accounting is a system of accounting that essentially makes sure that you can balance your credits and debits for handwritten ledgers, right? So a naive person who starts to keep their own accounts will put in a single file in Excel, and they'll put in their credits and their debits in a single column. And then they'll total them up, and then they'll notice at the end of the month it doesn't agree with their balance in their bank account. And then they have to go back and find out where they made an error. Well, double entry accounting keeps credits and debits in separate ledgers, and they must add up to zero. And you can do that total anytime you want. It's the magic of double entry accounting. It's been kind of made redundant by computers that are really good at addition. But in the old days, when you had to do this manually, double entry accounting stopped you making those errors. Another facet of double entry accounting is there is no erasure. You must rectify all errors and faults with new entries in the ledger. So if you make a mistake, you don't erase it. You couldn't. It's handwritten down. You could try and rub it out or overwrite it, but that's dumb. So you must fix all errors in the accounting by adding new accounts. So if you'll see in accounting practices, you'll see error corrections. You'll see it in your own accounts. If the bank actually makes a mistake on your credit card or in your accounts, they won't erase that transaction, they'll add something back. But it was invented by this guy in the 15th century, and you can draw a straight line from double entry accounting to event sourcing today. And it's used in relational. Relational database log files are event sources, a series of transactional records that represent the total state of the system. An event source is exactly that. It's the total state of the system captured by capturing every event that brings you to the current state you have today. And we've all built systems when we started out in this career where we updated in place. And then we realized actually we needed that data that we updated over and overwritten. And then we went back and we started to add log entries or character entries. Well, databases have been doing this from day one. Because if you lose your data files, the only way to recover that data is to blast through the log file and restore your state. But it's not just relational. MongoDB and all of the NoSQL vendors, just let me tell you, nobody's doing anything special here. MongoDB does the same thing. So we're a distributed database. We'll automatically keep up to 50 copies of your data in what we call secondaries. Primary is used to take in reads and writes. And when we asynchronously replicate to the secondaries, and we asynchronously replicate through a thing called an op log, an operations log. And what an operations log is exactly like the log file in a relational database. It's an idempotent log of all the operations that the primary has accumulated. And what we do is we play the op log into the secondary. Now, the op log is actually consumed by us and then discarded, because once the secondary is up to date, we've got a complete replica of the data set. But you can take the op log, which is, again, just a MongoDB collection, and stream it into your own collection, and you will effectively have an event source of your complete database forever. And customers do this so they can recover. And in fact, our own backup systems that we use for MongoDB use a similar technique. So again, nothing new under the sun here. So think about it from the point of view of somebody starting out when they don't really think about event sourcing. And this is a system I built in 2006, but we've all done this. I have a hard disk and I want to back it up. And the way we used to do that before we had things like CrashPlan and internet backup is we plug in a hard drive, or God forbid, if you're as old as me, a floppy drive, and you drag and drop your files onto this backup disk. Beautiful. So I take my file.jpg and I whack it onto this disk, and that's great. And that's fine for one file, but imagine you drag a directory with 50, 100, 1,000, 100,000 files, right? Nobody here has ever been able, unless you've got some kind of eidetic memory, to visually inspect any directory of files and say that they're the same, right? And it gets worse. What happens when I do this and then I go away for like a month or a week and I change the data set on the source and now I want to back it up again and I'm like, well, what's changed? Well, I can't throw out the old data because I'm not sure if I've deleted it or if changed it. So I move that directory to one side and I do another copy all over again. And now I've compounded the error. I now have two directories which are more or less the same but different. And now I've got three sets of data I can't compare or analyze. Well, that's not going to fly. So we do what everybody does. Let's use a backup tool. Backup tool keeps an event log, the event source of all the files that are copied from my source directory to my target directory. And now I've got state. I've got reproducible state. And this is effectively an event source for this backup system. It's not a complete event source. You can't reconstruct the data from these files, but you can reconstruct the state they were in when they were backed up and the state they were in the backup directory. Now we're starting to use event sourcing, and this is what event sourcing is. It's capturing the state as a continuum of events throughout the life cycle of your program, as opposed to capturing snapshot states, which is, here's all the files I backed up on the 27th of March. And of course, if you move to a SaaS backup system like CrashPlan or Backblaze or whatever your favorite file backup service is, this problem is compounded to hundreds of thousands to millions of users. And they all have files, and they all have different files, and they have different file directories. And if you want to look at that system, well, they do something exactly the same. They create every file as a series of events. In fact, if you look at CrashPlan, which is the one I'm most familiar with, they don't think of the world in terms of files at all. Files are just metadata. They think of the world in terms of file blocks. And so when you upload a block of data to CrashPlan, it says, I probably have this block somewhere already, because it turns out, apart from our own photographs, 90% of the data we install or put on our software, on our data, on our systems from vendors, is replicated across the whole environment. So when you're backing up your Microsoft Office installation, odds are all the blocks that you have are also on the laptop of the person next to you. So they treat the world as a series of block-level events that are related back to the files. And because of this view of the world, they're able to keep a very high resolution block map of the world of their backup. And this is why companies like CrashPlan can look at the block structure of their data at this fine-grained level and be super optimistic or optimized about how they back this stuff up. They can also look at blocks that never, ever get recalled, right? Imagine you've got a pile of blocks, and the dirty little secret of backup is 99% of the data is never, ever touched again. Well, you can run compression algorithms on that will make your eyes pop out. They take a long time to compress the data, but you can get 3, 4, 5 times the compression ratio of zip. And so that's why companies like CrashPlan can offer you unlimited backup on all of your data. And they do it by treating the data as an event source of key block level events. So where else is this kind of event trapping useful? Well, remember taxi cabs before Halo and Uber? Well, if you were a taxi cab company, your representation of your data was, first of all, eventually consistent because you didn't know until the end of the day how much each taxi driver had brought in because there was no credit card payments, it was all done in cash. And second of all, the meters were disconnected. And third of all, you didn't know if the taxi driver was actually putting the meter on or if he was running the meter correctly or if he was taking the person halfway around London on the way from Trafalgar Square to Piccadilly Circus. Well, Uber changed all that, and Halo did here in London before Uber. They turned every taxi driving event into a sequence of events: booking, cab pickup, and then a discrete set of geospatial steps that mapped you on this journey. And as a result of that, they turned taxi hailing into a big data business, right? Instead of it being like, I get my cash at the end of the day and I really have no clue what happened. Now Uber has deep insight. Halo has deep insight into what the business is doing. And that is done because they've event sourced that business. And the reason they're able to do that is because you can now get data stored in Amazon, which is where both Uber and, well, not Amazon, well, yeah, Amazon as well, keep their data at like sub 5 cents a gigabyte at the glacial rates. So you can keep all of this data. So one of the reasons event sourcing is so timely now is the old, even 10 years ago, keeping every event for everything that's ever happened in my business, it was crazy. It was like too much storage. You can do that now. And the whole point is capturing all of this data, all of the things you put in and out of your basket on Amazon, all of the steps you take in getting to that basket, gives Amazon the deepest insight into you as an individual of any vendor in the world, including your local shop or Tesco's or wherever you buy your groceries. And that deep insight comes from keeping this event source, because one of the things about event sourcing is we can't predict what the business will ask us next about our data. So you're making a presumption if you say, well, actually, I only need to keep this data. I only need to keep this state. It's like a bank saying, I'm not going to keep all your transactions, I'm going to throw them away and I'm just going to give you your bank balance. And then you're in dispute and they're saying, well, all we know is you've got $500 in your account or 600 euros or 400 pounds sterling. And you're going, well, I don't agree. I didn't get that. I actually am very disciplined. I use double entry accounting in my Excel spreadsheet and I know I should have $450. And they're going, well, sorry, we don't have that data anymore. Or if you're in Amazon and you're a business manager and you want to know, can I run an offer on people in the London metropolitan area who've put over $100 of goods in their basket but won't order them because it's going to cost them too much shipping? I can run an order, I can run an offer on that, even if they've taken the basket items out to reduce the cost. So having this data allows you to do queries and questions on business questions you can't predict. And that is the beauty of event sourcing. By breaking down your businesses, by breaking down your systems into a discrete set of events, you get much deeper insight. And I'll give you a classic example of this. Who here has booked an airline ticket in the last 3 weeks? Right, me too. Well, do you think that there's a big database at the back of that just says, there's a book ticket row or a ticket seat row? It's way more complicated than that. There's loads of systems involved. But their states, their commands are like, come in, look at the flights. I need a particular flight on a particular date. Look at the seats. I need a particular seat. Or I don't care about the seat. I just need any seat in that flight. Then there's the additional options. I might need a rental car or a Heathrow Express or local transport. And then there's got additional services on the plane. All these are accumulated events in the system that happen long before you pull the transaction lever to actually allocate that seat. But in the event sourcing world, you're running pre-allocations. Pre-allocations are key events in the seat booking scenario, where you're essentially booking a seat in advance of actually the customer paying for it. Because, of course, if I don't pre-allocate that seat, we might have thousands of customers looking at that. So eventually you reach a point where all the seats are pre-allocated. And, of course, we've all had the scenario where our seats have been overbooked. The customer or the airline will run overbooking here because it expects some percentage of the passengers to drop off the system before the booking's complete. And if they're good at it, you don't turn up at the airport and get asked, do you want to take a €500 voucher to take a flight some other day? If they're bad at it, and really bad at it, you'll be told you've been bumped off the flight. That happens. So how did I get here? Well, this is it. The whole point of event sourcing is, I don't know what you're going to ask me next. That is the essence of event sourcing. By keeping all of the events in the system, by understanding all of the transactions, by looking at all the states that you can capture, you can answer the business's next question, which is something you definitely didn't think of. So think of it as the ultimate agile approach to development. We absolutely want to be flexible in the levels of business functionality we give, but if we don't capture all the data, we can't go back in time and ask a user, what were you thinking about when you put that basket into an item, put that item into a basket and took it out again? We can do it now because it's so cheap. Storage is cheap enough to keep all the states. You can actually, and one of our customers does this, now archives off all the sensor data from all of the factories that it uses in continuous manufacturing. Why? Because in the old days, well, that data would be thrown away the minute it was captured. If there wasn't a trigger state, you just threw that sensor data away. You couldn't afford to store it in an Oracle database because, one, Oracle's super expensive, and two, the disk storage alone would kill you. Now they keep all that state because they can now do retrospective analysis, because often what happens is in continuous production systems, the tolerances that cause failures don't ever reach the alert threshold. So they can go back retrospectively and look at data for systems that failed, and now go back and do analysis on those areas and say, well, actually what we found is this threshold was set too high. It should have been 5% lower. We would have gotten an alert, we would have turned that system off, then we wouldn't have destroyed this multi-million-dollar piece of continuous manufacturing machinery. And trust me, when you turn off continuous manufacturing, it's about the single most expensive event you can do in the world. Anybody ever turned off a smelting foundry before? Once it solidifies, nothing you can do about it. So what's in the box? What do you get? What do you look at when you look for an event sourcing system? What are the things that make you an event sourcing system as opposed to just a database or just another database? Well, an immutable append-only log. Why immutable? Because if you can change history, you're destroying the utility of your event source. If somebody can go in and do an update on a record, remember the double entry model? No updates. You always rectify. So if somebody books a ticket, and God forbid we're ever allowed to cancel airline tickets without it costing us money, then that cancellation becomes a countermanding effect. We don't delete the entry where you booked the ticket. So the immutable log gives you a couple of nice properties. One, it can be very performant. Two, append only is very easy to recover from errors because you either have an entry in the database or you don't. If you're doing updates, and especially multi-document updates or multi-row element updates, you can't predict what's happened if an update fails halfway between the network sending the packet and the packet supposedly arriving at the server. With an immutable log, it's very easy to tell if the data arrived or not. So it simplifies your programming model. In fact, for a lot of event-sourced applications, you won't even put an index on this system. Why? Because indexes are expensive, and of course once you put one index on, you want to put a second index on and a third one, and suddenly you've killed the performance of your immutable log because you're updating 4 different write areas at the same time. Now, you can do indexes, and people do, but in the purest sense of the word, you should be able to just effectively throw that data into the log and parse it out later. So how do you get performance? Well, you use snapshots to get point-in-time state. So I don't find out what your bank balance is every time somebody goes to an ATM machine by summing up all your credits and debits since you opened your bank account. Of course, I take a separate database or a separate table or a separate collection in terms of MongoDB, and I'll run snapshots. So for accounting purposes in ATMs, your snapshot is literally the summation of everything you've done right up to the current time. So every time you put in a new ATM transaction, you take money out, you pay for something with your debit card, we're updating the snapshot. And that typically happens in large banks with an operational database. So the mainframe, and trust me, at the bottom of every high street bank in the UK and in Ireland for that matter, where I come from, there's a mainframe. That mainframe is updated with an overnight batch. And that batch is your system of record. When they want to know exactly how much money you have in your account, that's the system they go to. Then there's an operational database, which is effectively a snapshot that sits in front of that. That has your current balance as of last night, plus any transactions you did today. And that database is designed to give you real-time access. You can't do real-time queries on a mainframe. You can't do anything real-time on a mainframe. They're all running massive batches. They're either doing read batches in the day or update batches at night. So the most you can do in most banks is ask the mainframe for a data about once an hour, tops. So this operational data store becomes your snapshot store. And it's essentially got your credit balance, your debit balance, and various other bits of information like your home address and so on. And that's where you will generate, for instance, bank statements and updates when you look online in your ATM banking. So those snapshots are what we use to query the data in real time to get up-to-date views. And it's also what we use when we want to run commands on the system to add new transactions. I typically won't accumulate a transaction over the event source itself. I'll look at the snapshot, which will give me current state, and then I'll generate a new state based on I'm going to book an airline ticket now, or I'm going to back up a file, or I'm going to send a new event from an event source like a sensor. So where do events come from? I'm going to drift a little bit into the domain-driven design here as a segue into CQRS. Well, we've got business events. I want to book an airline ticket. We've got commands. Commands are like, I'm looking for an airline flight between Dublin and London. It's going to be on this particular date. That's going to generate events, which is essentially interest in flying. Now I'm going to go and do some kind of pre-allocation if I'm an airline and say, okay, do I have even any seats on any planes for London on this date? Yes, I do. Now I've got the menu for him. Then I'm going to go in and I'm going to pick a flight. That's another command. Pick flight, pick day, pick time. Then I'm going to go in and I'm going to generate a seat selection maybe, or I'm going to book additional travel. So these commands then work through this route aggregate. This route aggregate is essentially something identifying me, the seat on the plane itself, and then it pans down to a set of values. So really, you're looking at events that come in as commands and as route aggregates. You don't really generate events from these sub-aggregates or values here. This is what's recording these values into the event source. And so what you end up with is a sequence of saw a flight, picked the date, picked the seat, made a credit card payment, checked in, turned up on the flight, flew the flight, left the flight, went home. And now I've got a complete state of all of your travel, plus all the other things you did on the airline website. But the key thing is commands are first-class objects in this environment. They represent the things I do as a business user that have real object actions in the code base, right? And those commands then work on root aggregates in domain-driven design terminology that generate the identifiable events that become the event source. And it's snapshots for a point in time. As I said, think of a bank balance. The snapshots give you any point in time state you need. For an ATM, we need it literally every minute or every hour or so on. For a sensor network for a manufacturing plant, well, the sensor alerts are going to go straight to the console, but they're probably captured about once every couple of minutes. We don't need a summation of that state. In fact, we may not sum the sensor network state for a manufacturing plant at all. We just dump it somewhere for future analysis. Or for Halo, they probably don't need real-time updates on what the car data is doing, or for Uber. They probably capture that maybe once an hour. That's what they really need to know in terms for credit and debit. So some examples of snapshot queries that we would generate that are hard to produce from an event source. What purchase orders failed to get approved in Q2? Which cabs that were billed more than $50 a journey? I have to look at all the journeys and see all of the values that are over $50 and the ones that actually completed a booking. Which cabs get the biggest tips? I'd love to know who's providing the best service. How many baskets have had $200 in it for 2 weeks or more on an e-commerce site? Or which sensor events exceeded the safety threshold on 21st of July 2016? All of these require you to reach into the event source and can be optimized by capturing the appropriate level of snapshots. And think, snapshots are not fixed in time. You might start off capturing a snapshot which is once a week. Right? And then you'll discover your business wants daily snapshots, so they want real time. This is exactly what happened in banking. When you generated statements and there were no ATMs, you just needed a statement once a month, right? Then it became moderately real time with ATMs, and then it became super real time with debit cards. This is perfectly doable. Why? Because you can take that event source, you can run a Hadoop or a Spark query on it and generate these snapshots in super quick time. The compute infrastructure is there now to process all the data in near real time. Again, 10 years ago, this was a trickier problem because you had to run your own compute cluster and build all this Hadoop stuff yourself. Nowadays, generating new snapshots from event sources becomes very easy to do. And you can do it in MongoDB with our Smart Connector or use whatever your favorite Spark thing is. I'm a bit of a bigot about Spark. Spark's just so much easier than Hadoop. Anybody using Hadoop for doing computation now, it's like saying, I don't like those high-level programming languages. They keep me away from the hardware. I want to write everything in assembly language. Right? That's what Hadoop is. Go with Spark. It's easier, it's quicker, and it's faster. So, one of the things this leads to is you've got this event source and you've got your commands, but customers want lots of read-only queries. Our business customers, our real customers, lots of people dumpster dive for flights and don't ever book anything. And there's lots of read-only queries that happen. So how do we optimize our systems to get these queries without interfering with the performance of the event log? We don't really want to be parsing the event log for new snapshots. We don't want to be hitting the snapshots themselves because the snapshots are designed as much to give you accurate command execution because the commands have to be super consistent. So two things came to mind. So a developer called Bertrand Meyer in the 80s invented a programming language called Eiffel. And Eiffel came up with this idea called command query segregation. And it's not a new idea for anybody who's a functional programmer. The idea was you have commands. They do updates to your data state. And you have queries. Queries are not allowed to update state. You can't run a get on an object and have it change state behind the scenes. And this was a rule in Eiffel. And I guarantee you, whether you're programming in C or Java or Erlang or Perl or Python, whatever your favorite crazy language is, you follow that model, life's going to become simpler and easier for you. And then primarily the kind of Windows camp, but it's drifted into other environments, came up with this command query responsibility segregation. And it's an extension of CQS to allow you to model a system in which you optimize commands for being strongly consistent and queries for being eventually consistent. Who here absolutely must have reads that are strongly consistent? Who thinks it's absolutely mandatory in their system that reads need to be strongly consistent? Awesome. I feel like just leaving now because I think my work here is done. You'd be amazed the number of people who are more naive than yourselves who say, oh, I gotta have strongly consistent reads. I gotta have strongly consistent. Bank balances have to be strongly consistent. And which I say, so at what point do you need the strong consistency? Is it before the packet leaves your internal network, or is it when it travels over the 3G network, or is it when it reaches the phone? When is it strongly consistent? So CQRS makes a couple of assumptions. It says we're going to split the responsibilities into commands and queries. This is the segregation part. So this is your event source. Your domain objects, your commands come in and they use snapshots to give you efficient responses to queries that might want to say, are there any seats available, right? But really all they're doing is updating events and using snapshots. And this has to be strongly consistent because guess what? There's no point in me booking a seat on an airplane if there are no seats left. So when I do a pre-book of a seat, I might have a fudge factor which says I can overbook my flights by 10% because I expect 10% of the passengers who book to abandon it before the end. But effectively, within that context, it's strongly consistent. But over on the left here, my left, your right, we're capturing a completely different set of data, which is queryable data. So this is optimized for writing. It's an immutable log. It's not designed for querying. It's designed for updates. Over here, we might have a structure that's designed to be queried. If you were talking relational, what you'd have here is a highly normalized database, very efficient to write, but you'd be joining for the rest of your life if you want to do queries. Over here, you'll have a highly denormalized database, which is perfect for asking for all the data in one big chunk. One of the nice things about MongoDB is because it's actually a JavaScript object notation database. We store JavaScript. We don't store rows and columns. Every object is a JavaScript object, so you can store hierarchy. You don't have to do as much transformation to get from an event-sourced inbound service to a queryable service over here. There are some transformations that make more sense, but by and large, the JSON objects that you store on the event source don't have to be transformed too much to make a queryable environment. And so these queries and these query objects are optimized to just read the data. And there's a latency, obviously. There's a latency between the events and the snapshots and what gets in here. This is, I mean, if it's on the same cluster, you can use our aggregation framework to whip that into a new collection. More likely, it's going to be on separate clusters, and you're going to have a Kafka queue or an Akka queue or an MQ queue, whatever your favorite queuing thing is, that will stream the data from the domain space into the query space. And it effectively says one of these is for strong consistency and updates, and the other one is for eventual consistency and reads. So you're never going to read this side in order to satisfy a command. You always do your commands from this side. So the querying is just read-only. So in your web application design, you might seamlessly flip from a viewing interface that's delivering this stuff to when I go to book, well, then I cut over to the domain side, and then when I go to book, it's actually going to go and check flights for me. Or you might run a pre-allocation as part of your query. So the query gives you the number of flights, but when you go to check on a particular flight, we actually run a command to check whether there's any flights available. So in MongoDB speak, we do this a little differently to SQL. Because domain objects can be mapped directly into the database. Remember, it's JavaScript object notation, so you can drop a highly hierarchical, deeply nested object straight into the database. No object relational mapping required. And more importantly, you can change the structure of that object from one insert to the next. So if you update your domain object and you add new fields, you can just insert those straight in. You don't need to do an alter table. This is what we mean by dynamic schema. So you can inject brand new object types. And what we do is, this is the most simple model of a production cluster in MongoDB. We've got a 3-node cluster. This is what's called a replica set, because it keeps replicas from the primary to these two secondaries. You can have up to 50 of these secondaries. And what we do is, domain objects write into the primary, and the primary may contain snapshots. And if I read from the primary, I'm guaranteed to get strongly consistent data. So the domain objects and the commands that they generate know that they're seeing a consistent view of the world. Meanwhile, the secondaries are replicating the data for redundancy, for failure. So if the primary dies for some reason, one of these secondaries will automatically be elected, and it will not impact the domain at all. So the most that would happen here is if you're in the middle of a transaction, you may have to retry. And one of the great things about retrying transactions when you've got an update-only log is you can look into the log and see if that transaction went through or not. If it's an append-only log, you can see, well, I get a failure, which is essentially a network failure, for instance. MongoDB will give you a connection failure. MongoDB is designed to handle any one connection failure, and it will make queries wait at this point till the primary is re-elected. Then you can retry, and you only need to retry one time, because if it fails a second time, your whole cluster is dead. That's the point at which you have to escalate an error to the rest of the system. But in most healthy clusters that are recovering correctly, you'll get a recovery in about less than 3 seconds. So we've got stable data written to the primary and to the secondaries. We've got the ability to do strongly consistent writes and reads. So now what we can do is we can take one of these secondaries and effectively mark it as a hidden member. That means it's never going to become the primary. That means it's got an eventually consistent data set. And I can read the op log off this secondary. The op log is essentially, remember, the history of all the transactions. Or I could just read the events. I can actually just look at the collection and say I want to see the latest events that have come in by doing a long-running cursor query. And if it's in the same MongoDB cluster, we've got a thing called the aggregation framework, which will take this data and dump it into a new collection on a new cluster. If it's on a different cluster in a different network, if you've got this running in Amazon and that running in Azure, you can stick a queuing system in here, Kafka or Akka or whatever your favorite queuing entity is. And again, these writes go into the primary, strongly consistent, but this is effectively a write-only node. We don't query from this node. Instead, when these queries are replicated to the secondaries, we distribute the reads over all the secondaries. This means we're optimizing one node for writing and the rest for reading. Now, I know you'll say, oh, hold on there a minute. What happens when you put like 100,000 concurrent transactions? That node's going to blow up. Well, I haven't shown it here, but you can replicate these clusters themselves into what we call a sharded environment. So you've got multiple primaries, and that's how you scale out. But as I said, 99% of the people in this room are never going to have 100,000 concurrent users. I've never had it in the history of my time in computing, and I've built a lot of systems. I'm sure I will before I die, and I know we've built MongoDB clusters with 100,000 users, but I don't write code for the core MongoDB system. I'm an outside-the-core dabbler. So the bottom line is at least half our customers run whole businesses on a single replica set. And with this model, they can run CQRS, and I can use the aggregation framework to pivot the data. I can say, I don't need this data, or I just need a snapshot of data, or I just want to copy the snapshot data. I might not want the full event source. I might just want to grab the snapshots and do queries off the snapshots. If I'm a bank in 1990, I'm only offering monthly statements, well, then I only need the monthly snapshots. So that's all I copy across. But if you wanted to do rich querying or do analytics on your data, and one of our customers in the airline industry actually does this with all of the airline data for one of the big airlines in UK, you'd grab everything, and everything would be put in the queryable environment. And in their environment, they don't set any indexes up on the query database, because what they do is they keep it all in memory, and they essentially do data warehouse type queries where essentially they don't use the indexes, they just query the data with table scans. So you've got a variety of opportunities here to build this. And of course, in the trivialist of cases, you just don't have a query section. You just keep it all here and you can query it directly. And this is what I mean about building up from the ground up. CQRS is a design pattern that you probably don't need unless you've got hundreds of thousands of people using your system concurrently. So you can keep all the commands and queries in this one database as a simplification. And so you can imagine using the purchase order example, which I'm slightly ashamed of, but it seems like everybody here in the world of software engineering is building ERP systems. You could start off with an object that looks like this, and I've extended it with line items, which I've elided, and VAT and total price and currency. But you can see yourself adding anti-fraud data here. And if you decided to add anti-fraud data, one of the wonders of MongoDB is you can just drop that into this object and start inserting it. The database is not going to prevent you from doing that. In fact, it deliberately doesn't prevent you from doing that, because dynamic schema gives you the ability to change the schema without running an older table. All the old code will continue to work because we're querying JSON. And the old code never looks for these new fields, so it's fine. I can also choose to build indexes at any level I want here. So I might want to index on total price because I want to be able to do very efficient summations on the total price of data. I might want to index on company number, which is nested inside purchase from. I can also do that. I might want to index on VAT ID or indeed address. The point of the matter is you can choose how to model your data and to make it efficient to query. And our query language, of course, allows you to reach into every level of this JSON structure. That's the beauty of a JSON database. And because you have this richness, it means you don't have to do the thing that used to drive me freaking crazy, which is we've changed the objects in the code. Well, the database administrator will come up to you and go, well, we've got to alter the table. Your ORM wants a new table there, and so we're going to have to take the database down this weekend, so we're going to have to schedule that. The number one reason our more traditional customers love MongoDB is they don't need to wait for the DBA team to run an alter table to change their schema. And that makes them 1,000 times more efficient because they're not queued up behind the other 1,000 schema changes that are waiting for that DBA team, which is massively overstretched. And it plays beautifully into the more modern DevOps model of deploying straight into production and making sure that you've constructed your production environment so it can take that deployment without killing all your customers. That flexibility at the database level is what gives this schemaless design or dynamic schema its wild attraction for modern developers. So, in summary, event sourcing, a goofy name, but it's really capturing all the state of your system as first-class objects or command objects, and understanding that the simplistic business event, which is I want to book a flight, can actually be broken down into a whole range of command events which can be represented in your system as events in the event sourcing database. CQRS, optimize differently for queries for commands and queries. Split your system if it makes sense. CQRS is one of those design patterns that is immediately appealing for younger software engineers who've read so many books and so many articles on scaling that they think that scaling is the number one problem. And beating that out of young developers is one of my most enjoyable jobs. Right? You don't need to scale. Premature scaling is the root of all evil, to paraphrase another famous computer scientist. MongoDB is ideally suited for your event store. Why? Because the documents it stores are an exact representation of your command objects. You don't need to ORM yourself to death. And ORM is a pain in the hoop. I'm sorry. I know relational is great and everybody uses it, but it's just not good. one of the things I didn't talk about is one of the things we can do with MongoDB is you can choose the storage engine. So you might want to run your query engine as an in-memory engine, right? And so all the queries are super efficient. They might take a while for the data to percolate through. Or you might want to run an in-memory node and have two backing nodes on disk. So the in-memory queries are served, but the backing store gets up to date eventually consistently. Or you might want to run the primary on the right side in memory and have two backing nodes which are on disk, or 3 nodes on SSDs and 2 nodes on spinning disks, or 3 nodes in a data center A and 2 nodes in data center B. The richness of the topologies you can build with MongoDB allows you to be as inventive and clever about your data durability and your performance as you want to be. And then the final thing is MongoDB comes with an aggregation framework, essentially a data pipelining tool exactly like Unix pipes that allows you to query data, to group data, to match data, and to run analytics on the data in the database engine. So you can essentially say, I want to see all of the events associated with booking an airplane from Dublin to London for over $400 where the booking was cancelled just before the credit card was nominated. And that will all happen inside the engine, and it will generate a brand new collection for you, and a brand new table for you relational people that you can now do your analytics on. So the aggregation framework gives you the automatic capability to generate your snapshots on demand. That's MongoDB and event sourcing. I hope I haven't kept you from the bar for too long. I'm happy to take questions for a couple of minutes. I think we've got 2 or 3 minutes left. Or you can come and ask me about what I talked about afterwards. Or I'll meet you in the bar. Shoot. Chung, chung. This guy first.
How do you handle data privacy and deletion of data? So to give you a concrete example, for example, you have a company and then you allow your clients to put some personal data, and then you allow them to delete everything that they have done because of privacy laws or something. And if you have a mutable law,
who do you know that offers that service?
I know about the law.
I know you know about law, but tell me a company you know that tells you when they delete your data, it's gone forever.
No, I don't know. That's why I'm asking.
Nobody deletes your data forever, because I'm telling you right now, they can't go back into their backups. They're not going to go back into their backups and delete your data. So it's there. They're not going to go back into this, the surrogate copies. They're not going to go back into their paper chain, right? So I can delete your data from the event source. Absolutely. Look, it's a database. You want to delete a row in the database? Remember, it's an immutable log, so there's no links to anything. There's no foreign references. If I have to delete the data, I will. But anybody who thinks data is actually getting deleted when they run a data protection thing is fooling themselves. It's there somewhere, and if they want to get it, they will. So what they would probably do, what I would probably suggest they do in this system is you would do an update on the event log where you would obliterate the record data but leave the record information intact. That way you could still do analytics, but you just wouldn't know it was Joe Drumgoole anymore. It would be XXXXX. So that's possible. I mean, you know, remember, it's a database. These are conventions. The database is not stopping you from updating in place. So you can do that. But be careful what you wish for. You're not getting that data deleted. You're getting it deleted from the one active table. The backups, I'm afraid it's there forever. Nobody's going into the backup tables and getting rid of your stuff. Sorry, this guy was first, and I'll go to you.
So I have like kind of 2 questions. First one,
no, only one question per person. Come on, bring it on.
Okay. So you talk about the separation of the segregation of the responsibility of comments and queries.
Yeah.
And you talk about the strong consistency within the rights.
Yes.
Of the common party.
Yes.
So how this is exactly guaranteed? Because sometimes, for example, for booking, as you made as example, if you are going to make a book, you need to query. You need reads also.
Yeah, but you read from the snapshots on the query side. The snapshots give you up-to-date state, and the snapshots are as relevant as you need them to be. If you're a bank, you have a snapshot for the state of everybody's account based on the last transaction they ran. And so you're updating 2 things. You're updating the event source, and you're updating the current state. And that's That's how you do that. So the snapshots give you consistency of the data. You would never go to the query side. The query side is probably hundreds to thousands of milliseconds out of date, depending on where it's hosted. You had a second question?
Yeah, is the latency between these two parts?
Okay. Depends on, if you're a high frequency trader, they talk about sub-microsecond delays. If you're a normal vendor and you've got stuff in 2 Amazon regions, the likelihood is you're probably talking about a couple of hundred milliseconds of delay between the primary on the query on the command side and the queries on the query side. But you can make that more efficient. I mean, anybody who's willing to spend money on this problem can make that delay go away, but it's expensive. Sorry, there was somebody here.
Yeah, keeping the snapshots up to date, is it up to you to decide the trade-off, or you want to apply each transaction to the snapshot as it comes in so that you can query it consistently for your own view? Does that apply to other?
Well, there are no transactions, let's be clear.
Okay,
right? So you are responsible for keeping the snapshot up to date in a way that makes sense for your environment and your application. And what makes sense is different for a bank than for an airline, than for an Uber, than for a Halo. So lots and lots of companies don't need strong consistency on the command side because, you know, I'll tell you exactly what happens at Halo in Dublin, where I'm from. You get a Halo and then the Halo goes away because it's like, well, I booked this Halo, but somebody else booked it, and the first person got query. And once we realized there was a collision, I canceled your query. But it's book and cancel. You rectify the error with a new event, because that's important data, because I'm getting lots of collisions. There's either a problem in the system, problem in my algorithm, or a problem in the way the cars are being connected to.
Do you end up with duplicating the code that creates the snapshots from a previous snapshot, like evolving last night's snapshot to tonight's snapshot? Does that look over the event log in the same way that the log?
Yeah, I mean, you can take snapshots from snapshots, but you obviously get a problem there. Ideally, you want to create all snapshot views from the event source because they're strongly consistent. If you're creating snapshots from snapshots, you really should be putting it on the query side and have it and acknowledge that this stuff is going to be less consistent. Down the back there.
The process of consolidating, I think I got 3 years of evidence stored. My schema has changed a lot.
Yeah.
Not always adding fields, but
Yeah.
changing fields that are already there.
Yeah.
I guess reading this actually got a little bit of a mess. Otherwise, you ask for some versioning,
Yeah.
everything goes out of hand. Are there any consolidations?
Again, it's a personal choice. This is a guideline like all patterns. You can absolutely say, you know what, I don't care about any taxi bookings I made before 2015. Life's too long, and I don't really care. And I'm just archiving that off. And I'll just take that data out, put it in a dump, or stick it on Amazon Glacier, and leave it there. I mean, the thing is, why would you throw it away? Because although you think you don't need that data now, I guarantee you. I'll tell you a classic case in point. So I run the community in Europe. We run it on Meetup. Meetup has a beautiful API for getting the data, but it has no history. So I don't know, is the community growing or shrinking? So I've built an event-sourced environment that takes a snapshot of the Meetup data every week. Now, I can query that event source to find out what the total state of the MongoDB environment in Europe is. And this is all in GitHub, by the way. You look at a program called Muggalizer. It'll grab that data and give you a snapshot, and it's batched, and it's essentially an event-sourced view of Meetup. And it's the same thing in Salesforce. And who here uses Salesforce or has had the painful job of using Salesforce? Salesforce is a point-in-time database. And more importantly, you can't use Salesforce to run your business because changing things now changes things that happened in the past, which is death to anybody trying to do analytics on what we sold and what we bought. So you need a separate thing which takes a snapshot of all the data in Salesforce in time and puts it somewhere else. And that's essentially what the event source model is doing. But yeah, you can delete that data, you can reconcile it, you can compress it, you can do whatever you want with it. Remember, you own the database. The event sourcing model is not saying anything special. Yes, it's an immutable log until you decide to change it, but be careful what you wish for. If you change that log and then you come back and the business says, well, we want to do an analysis, or as happened in the banks in Ireland, the government came in and said, I want to see 14 years worth of accounts. And the banks went, well, we only have 7. And the government said, well, you better hop to it, because from now on we're going to want 14 years of accounts. It nearly broke the Irish banks because they didn't have the storage or the systems or the capability to store 14 years of accounts, never mind query them. So unless you have the prescience to know exactly what your business is going to want to do with its data in the next 10 years, my advice would be to be not throwing away data, not when it costs 5 cents a gigabyte to store it in Amazon.
I have one question. I don't know if it's a good question, but on other talks, there's been a lot of talks about distributed transactions.
Yeah.
You have a big transaction,
Yeah.
and you build a distributed system.
Yeah.
So you get a big distributed transaction, which is a big problem.
Yeah.
Do you think this event sorting is a way to break down a big transaction so you don't need to distribute?
The reason we don't have distributed transactions in MongoDB is because even the smartest people I know in MongoDB don't know how to make it work on a general case.
Okay, so
right?
my question is maybe, is the event sorting a way to break down a big transaction?
Well, it is that it's one of the benefits of the approach. Instead of having a transaction with a begin and an end, you have a transaction with a set of states, and those states can be rolled back and rolled forward, but you get a discrete event which gives you a checkpoint on that rather than, and it's basically like, you know, optimistic locking gone wild. You know, ultimately you're going to hope that somebody finally completes that booking for that flight.
Okay.
But yeah, distributed transactions are hard.
Is it a way to avoid it?
Well, I'm not a distributed transactions guy. I know a little bit about it. Whenever I've tried to do it, it's come a cropper for me. I try and avoid it. If you're building a system at scale, you can't do them. It's just not, it doesn't work. And if you're building a system that's small enough that you want to use them, my question would be, why do you need to use them? Why don't you just do it all in one database? You know, so when you finally complete your booking and write a credit card transaction and get your ticket, I guarantee you that's transactional in nature within the booking, with the airline booking industry, and it's transactional globally. This is what global distribution systems are all about. Amadeus and I can't remember the other one that's a transport, or what's it called? Travelport, thank you. Travelport's the UK one. Their business is making sure that when you finally go on paying for this ticket, it happens in a transactional way. So we offload that responsibility. I see people running for the bar. I feel like running for the bar myself. Any more questions? I will put this on SlideShare. If you just zip onto my Twitter account on Joe Drumgoole, you don't have to follow me forever. If you follow me for the next 24 hours, you'll see the link, and then you can leave. And if you've got any other questions, you can ask me on Twitter. Okay, thank you.